This video is about rational exponents. So when we have a radical, we can convert it over to a rational exponent or vice versa. So we have x to the 1/n power. That's just the nth root of x, where your numerator is the power and your denominator is the nth root. And then we have x to the m over nth power. This is the same thing as nth root of x. You take the nth root of x and then you apply the power, which is my favorite way of working these, or you can take the nth power of the base, then the nth root, which is not my favorite because by the time you take the power of a number, sometimes you get a really large number and it's harder to nth root it. I always like to nth root and then go ahead with my power. And then negative fractional exponents, you just use the negative exponent rule. So if you have x to the negative m over n, you can rewrite that as 1 over x to the m over n. So it does not matter if you have a whole number or a fraction. If your exponent is negative, you can definitely bring it downstairs to make it positive, or vice versa. It could be downstairs and you can pull it upstairs. So let's look at some examples. So if we have 9 to the 1/2 power, that is the same thing as the square root of 9. The square root of 9 is 3. We have the 16 to the 1/4 power. That's the 4th root of 16, or what times itself 4 times give us 16. That would be 2. If you're unsure, you can definitely break your numbers up. It takes 4 to break 1 out of jail. We can also apply the properties of exponents to our rational exponents. So for instance, if we have a to the 4th to the 1/2 power, we multiply a to the 4th over 2, or what is half of 4? Half of 4 is 2, so we have a to the 2nd. We can definitely convert the radicals over to powers. So we have 4th root of 5xyz, so we take the whole quantity 5xyz, and that would be to the 1/4 power. This would probably be good to use if you were adding and subtracting, or if you're adding, subtracting, or multiplying, dividing your terms and you want to combine them instead of using the square root or cube root, or 4th root in this case. So you can keep going back and forth. Again, it depends on what situation you're in. A lot of times it's easier to simplify this way or in terms of a radical. So let's look at 27 2 to the 3rd power. Again, this has no rhyme or reason, but if we turn it over to a radical, it's a lot easier. So the 3rd root, remember the denominator is the index, the 3rd root of 27, once we find the 3rd root of 27, we're going to take that to the power of 2, where up here we actually had to take it to the power of 1. Exponent of 1 is always that number. So cubed root of 27 is 3. 3 to the 2nd power is 9. And it is a lot easier to apply the root first and then apply the exponent, just like we did here. Otherwise, we'd have to have 27 squared, which would be the 3rd root of, or would be 9 to the 9 to the third power, excuse me. So it's a lot easier to work with smaller numbers first, then wait until they get big. Now we have 64 to the negative 1/2 power. Again, to make the exponents positive, you have to bring it downstairs to make it positive. This is the square root of 64. Well, the square root of 64 is 8. So 64 to the negative 1/2 power is actually 1/8. If we have 5 to the 2/7 times 5 to the 3/7, if we add those together, or excuse me, we're multiplying, so we have to add the powers together, the exponents together. 2/7 plus 3/7 is 5/7, and we'll just leave it at that. Otherwise, you would have to go 7th root of 5 to the 5th power, but this, since it was in fractional, you can leave it fractional. This would be used only if you had to go further, or if your directions stated to write your answer in radical form. We have a to the 2/7 power raised to the 3rd power. Well, 3 times 2/7, you multiply your numerators together, your denominators together, so that'd be a to the 6/7, and we leave it at that. A to the 8/3 times a to the 1/3, all over a to the 2nd. So we need to work our numerator. We add, so that's a to the 9/3 over a to the 2nd. Well, 9/3, that's 3. And then if we take a to the 3rd divided by a to the 2nd, we get a. So you can work these fractional exponents with the properties of exponents, just the same. And then you can convert your values over to the radicals. Let's look at another one that we have to convert over to solve or simplify. So we have negative 27x to the 6th to the 2/3 power. So we are going to give each of these items, each of these units, the power, and then we can solve them individually. Now this one, I would not necessarily turn it into a radical unless I had to do something with a radical here at the very end, or my answer involved a radical. So the first thing I'm going to do is go the 3rd root of negative 27, and this is to the 2nd power. So this will be actually negative 3 to the 2nd power, which is 9. So the negative 27 to the 2/3 power is 9. And then with the x to the 6 to the 2/3, we are going to multiply. 6 times 2 is 12. Well, we have to divide by 3, so we get x to the 4th. So our answer will be 9x to the 4th when we are done. So you can figure these individually, and then make sure you put them all together nice and neat as your answer. This will conclude this video.